Hello, my name is Thomas Dimitrovich. This session will review circuit breaker selective coordination tables. The estimated duration of this presentation is 4 minutes. These two circuit breakers are in series with each other in a power distribution system. For a short circuit downstream of device number 1, both of these devices will see the same short circuit current. Time current characteristic curves, as those shown here, are what you will see when reviewing a selective coordination study. This plot shows how these two devices relate to each other and respond when a current passes through them. The curves tell us clearly what happens for those currents in zone 1. Circuit breaker tables provide additional information beyond what the TCC curves show us for those fault currents in region 2. Using this example of a BAB20 downstream of an F-frame 150 amp thermomagnetic circuit breaker, let's review how these two devices respond when the short circuit current flowing through these two devices is 500 amps. 500 amps is into the instantaneous region of the BAB20, and so that device will trip instantaneously. It will take the F150 a maximum of 43 seconds to clear this fault. Selective coordination at 500 amps is achieved for this pair of devices based upon the time current characteristic curves. Should the fault current that passes through these two devices be 1000 amps, we recognize that this current is greater than the instantaneous pickup of both circuit breakers. Based on the time current characteristic curves alone, you may or may not be selectively coordinated. With TCC information alone, we would have to assume we do not selectively coordinate. This is where the value of the selective coordination tables are realized. The selective coordination tables present pairs of circuit breakers that for the most part have been tested to establish the current at which both devices open. The table is laid out in such a manner as you have the line side or upstream circuit breaker listed across the top and the downstream circuit breaker listed down the left side of the table. For each pair, the content of the table shows us the current value to which selectivity is maintained. Beyond the currents in these tables, both circuit breakers will open should they both see that current. For this example, an F150 upstream of a BAB20 will selectively coordinate up to 1500 amps. Beyond 1500 amps, both of these devices will open. Currents less than or equal to 1500 amps will see the BAB20 open and the F150 keeping its contacts closed, achieving selective coordination up to that number. For this example, a short circuit current of 1000 amps flowing through both circuit breakers, the F150 will remain closed and the BAB20 will open. Selective coordination is achieved as documented in the selective coordination tables. Should these devices see a current greater than 1500 amps, selective coordination is not achieved as documented by the TCC curves and the selective coordination tables. In summary, circuit breaker applications require calculation of short circuit currents. We should always leverage the TCC curves before using the tables and leverage the selective coordination tables of tested pairs when the TCC curve limitations are met. Thank you for sharing your time to talk about this technical topic.